Hi everyone. So just while people are joining us, I just want to introduce myself. My name is Laura Egan O'Brien. I'm the UCD College of Engineering and Architecture Marketing Manager, and I'm going to be the host for our webinar today. I just want to say a big welcome to the UCD Engineering Summer School. We are disappointed that we couldn't do our regular on-campus event this year, but it's actually worked out not too bad because it means we can reach a wider audience and engage with more of you, which is a good thing on our online event here today. Some housekeeping notes as people are joining us. Just to let you know, we are recording the webinar today. I'm going to pop up that recording onto our YouTube channel later on in the week. So if you miss anything or want to check back at anything at any stage, it'll be there for you, and I'll send you the link to that recording after the event today. And then also, if you have any questions that you want to ask us today, there is a Q&A button in the control panel at the bottom of your screens. Type your questions in there and we'll leave it towards the end of the webinar to actually answer them in case some of those questions get answered as part of the presentations you're going to hear today. But as you go, just put them in there and we'll get to them at the end. We are going to be running a competition also today. I will tell you how you can be with the chance to win that at the end of the webinar, so stick around to the very end. It is a UCD Engineering goodie bag and also a Just Eat voucher that you're in with a chance to winning, and it's really simple, so I'll tell you that at the end. And then schedule wise, you're going to hear from me giving an overview of our engineering program and the kind of structure of the degree itself. You'll also get 2 sample lectures, one from Dr. Philip Donlan on renewable energies and one from Dr. Colin Keogh on disruptive technologies. And then last but not least, at the end, we'll have a Q&A with 2 of our current students. So that gives you a chance to ask those questions that you want answered at the end. So I think we might get started. I'm going to share my screen with you, so you can just bear with me while I get that set up. Hi, my name is Laura Egan O'Brien. I'm the UCD College of Engineering and Architecture Marketing Manager, and I'm going to give you an overview of the UCD Engineering Programme. Choosing to do engineering in UCD is a great option, and there are many reasons why. We provide a world-class engineering education from leading academics. We're in the top 1% of universities in the world, and many of our academics are leaders in their field. We have one of the widest range of degree courses in Ireland. Students can choose to do civil engineering, structural engineering with architecture, biomedical engineering, mechanical engineering, electrical electronic engineering, or chemical and bioprocess engineering. Many of our degrees are also accredited by the relevant professional bodies. This is really good for students who are looking to get chartership after they finish their degree, or maybe want to work outside of Ireland. In the 3rd year of the programme, engineering students have the option to study abroad or Erasmus. This means that for either 6 months or a full academic year, students can choose to study in one of our partner institutions somewhere in the world. In the past, students have chosen to go to Australia, New Zealand, Canada, the US, or mainland Europe. This is a great opportunity not just academically, but also as a life experience, with students being able to live in a different country, experience the culture, and make new friends. For students on the 5-year engineering programme, there's also the opportunity in their 4th year to do a 6 to 8 month professional work experience. This is a great opportunity for students to put what they learn in the classroom into practice, and many companies use this as an extended interview, with students securing jobs when they're finished their degree. We have 2 internship managers within the college who build up relationship with these companies and help you prepare for this internship. The Career Development Centre is also open to students to do mock interviews, CV clinics, and workshops. For students who also have academic interests outside of engineering, there's the UCD Horizons programme. This means that for a couple of classes every year, students can choose subjects from around the university. Students may choose to pursue things like languages, zoology, archaeology, art history. This is great to make students more well-rounded, but also for job opportunities in the future. UCD Engineering also has excellent employment prospects with great links with industry. UCD also has a lot of supports available to our students, from student advisors to peer mentors, the Writing Support Centre, and maybe most applicable for engineering students, the Maths Support Centre. And while the main reason our students come to UCD is to get a great degree, we also want students to experience college life. And that's where UCD clubs and societies come in. A lot of our engineering students choose to join the UCD Engineering Society, Women in STEM, UCD Formula Student, go away with UCD Volunteers Overseas. There's also clubs for every kind of sport and societies like Harry Potter, chess, drama, music, film, whatever you're interested in. So for students who know engineering is what they want to do, how do you get into the course? So for the majority of our Irish students, they'll typically come in by doing the Leaving Cert and applying through the CAO system. The code you need for the CAO is DN150, and for students who came in 2019, the minimum points requirement was 511 points. Subject-wise, we're going to need students to present with English, Irish, maths at a H4, and a science subject at a H6. And this can be chemistry, physics, biology, or agricultural science. And then 2 other recognised subjects. For our EU students who are coming through the CAO system, we're presenting with A-levels or maybe the International Baccalaureate. You can find the requirements on our UC admissions website. And then for our non-EU international students, you can find out the minimum entry requirements by going to our UCD Global website. The structure of our engineering degree means there are multiple decision points along the way, and that students can explore their options before they have to make these choices. The first year of the programme is a common engineering year, with students studying fundamentals in maths and science, which is really important for engineering, and it's also good to get everyone up to the same standard from their second level education. Students then get to do introductory modules in basic engineering principles, things like Intro to Mechanics, Energy Engineering, Biomedical Sciences, Computer Science for Engineers, Intro to Civil and Environmental Engineering, or Creativity and Design. At the end of first year, before going into second year, students choose their pathway that they'd like to specialise in for the rest of the degree. Students can choose one of 6 pathways. As I mentioned, we offer civil engineering, structural engineering with architecture, biomedical engineering, mechanical engineering, chemical and bioprocess engineering, and electronic and electrical engineering. Towards the end of second year is when students choose if they want to go on their Erasmus or study abroad in their third year. And then at the end of third year, students choose if they're going to do the 4-year Bachelor of Engineering, or they'll complete it for their 2 years and finish with both the Bachelor and the Masters of Engineering as part of our full 5-year programme. And as I said before, if students choose the full 5-year programme with us, they get the opportunity to do that 6 to 8 month internship in their 4th year. So for students who want to know a little bit more about what the different disciplines of engineering actually mean, I'll explain a little here. Civil engineers are involved with the building and construction industry. They're also involved in building transport infrastructure, water and waste infrastructure, and planning. Another big area for civil engineering that's maybe a little less obvious is the area of sustainable development and environmental engineering. Civil engineers are looking at how we meet the needs of society into the future and how we do that in a sustainable way while also looking after the environment. Then we have structural engineering with architecture. This is similar to civil engineering, but with a much greater emphasis on structures, things like buildings and bridges. Students in this area will also take classes with our architectural programme and learn how to appreciate aesthetics of buildings and also to learn about the architectural design process. Biomedical engineering uses traditional engineering methods to solve problems in healthcare. And biomedical engineers work very closely with healthcare professionals. They improve biological and medical outcomes, advance healthcare, work on medical devices and instruments. And this is a huge area in Ireland. So there's great job opportunities. Mechanical engineering is the broadest of the engineering disciplines that we offer here in UCD. It covers everything from design, manufacturing, testing and operation of components, and it feeds into many industries such as aerospace, automotive, robotics, medical technologies, and the energy sector. Electrical engineering focuses on the use of electricity and focuses on the generation, transmission, and storage of this electricity, and is particularly concerned at the moment in renewable energies, things like wind and solar. Whereas electronic engineers design circuits and systems. They focus on hardware and aspects of software and programming that underpin digital communication, the internet, smartphones, and digital media. And last but not least, chemical and bioprocess engineering. This stream of engineering looks at how to transform chemicals and materials into other useful products and how to realise this on a large scale for production. Chemical engineers do this for many industries, including the pharmaceutical industry, the food and drinks industry, and also the oil and gas industry. Now, what kind of careers can you have as an engineering graduate? Career-wise, engineering is very broad and varied, so it follows suit that the careers would also be. Our graduates are finishing with transferable skills and a mindset that works for a multitude of different industries. We find some students go to work in more traditional and typical engineering roles in industries and sectors like ICT sector, the energy sector, manufacturing, medical technology companies, and pharmaceutical companies. And then we have students who maybe go the less obvious route into financial services, banking, professional services, and consultancy. Others are more entrepreneurial and may wish to start their own companies. Students work in companies sized anywhere from a startup right up to the large multinationals like Google and Facebook. We also have a smaller cohort of students who may wish to pursue further studies, maybe a research master's or PhD, and ultimately they want to go into research or academia. So it really is a very flexible and practical degree that affords a lot of opportunities to our graduates. It can take you a lot of different places, and you really can't go wrong with a degree in engineering. Thank you for listening, and if you want to reach out to us or find out more about life on campus, don't forget to follow us on our social media channels. Great, guys, thanks for listening to that. I hope it answered maybe some of the questions that you were maybe coming into today having, and then you'll get a chance to ask more questions towards the end. So I'm going to get our next kind of sample presentation started. This is Dr. Colin Keogh, and his presentation is about innovation into the future with disruptive technologies. I'm going to launch a poll just before I get that presentation up and running. It's just around the engineering disciplines that are people who are tuning in or interested in. So if you could just fill that in, that'd be great as well.
Hello, my name is Colin, and I'm going to talk to you a little bit about engineering, disruptive technologies, and that sort of stuff. A little about my background, how I ended up in engineering, some of the work that I've been doing, and kind of my journey from secondary school up to being a kind of practicing engineer right now. And then I'm going to talk a little bit about disruptive technology and loads of potential opportunities for you guys to work in if you choose engineering into the future. So a bit about me. So my background, my father was a car mechanic and he worked in a small little garage like this. So ever since I was a kid, I worked with him and was exposed to technology and engineering and that sort of stuff. So from a very, very young, early age, I was interested in how things worked, how to fix things, machinery, and cars in particular were the thing that I really kind of loved and still do. So that was my connection into engineering. So, you know, like an awful lot of kids, I was interested in Lego, in cars, in like Meccano, building toys, taking things apart, putting them back together. So this is me as I was a kid. So you see Lego blocks and cars. And this is me as an adult, which is basically the same thing. My Lego gets way more complicated and dangerous, and then the cars get way faster and way more fun. So my background, so I went to UCD and I studied mechanical engineering for 4 years. So I did 4 years mechanical engineering. I then stayed on to do another year and I did an ME in energy systems engineering. So I was interested in automotive technology, and then I pivoted into renewable energy. So looking at electric vehicles, biomass fuel, solar panels, that sort of stuff. I then stayed working in UCD as a research engineer for a good couple of years. Working on R&D projects with companies. I started a few companies. I was involved in a couple of external projects. I acted as a consultant for a long, long time. And then I went back to UCD to do a PhD. So I finished my PhD, and my PhD was in innovation systems and innovation methodologies. So I looked at, since I worked in the field of innovation and I was creating new companies and new processes and new innovations and machines, I wanted to look at how that works. So I looked at methods like design thinking and Lean Six Sigma and that sort of stuff. We looked at how processes allow people to be more creative and more innovative and create the next generation of innovation. So I finished that just the beginning of this year. And I imagine I'm going to stay working in that field now for the foreseeable future. So as I said, I worked in a consultant and as a researcher. So I worked on a large range of projects. So I like working on different projects all the time. So in different areas. So over the past few years, I've worked with like incubators and business spin-out systems, helping startup companies create new technologies and develop new like solutions, and then companies to go with them. I've worked on projects like in algae, which was using algae and like seaweed to create energy, plastic, food, fuel, anything and everything really. You know, I've done some projects with large car companies like Fiat, and that was integrating solar panels into the roofs of new Fiat cars. A lot of projects in sustainability, renewable energy, and applying new technology. So in addition to private ones, I've done an awful lot of research projects. So I've started and ran projects looking at recycling plastic waste, looking at connecting the community to waste in the environment and trying to find ways in which community can upgrade that and improve it. So a wide range of projects, and that suits me down to the ground. Like, my projects change every couple of weeks. I work in different areas in different countries with different professions and different backgrounds, and I love that scope and variety and flexibility in different projects. So as well as the research work, I do an awful lot of private consultancy work. So I work with universities and companies all around the world, like airlines like AirAsia, when we looked at imagining what the future of air travel would look like. I've taught and give lectures in places like Singapore and MIT in the US, and then an awful lot of development. So things like United Nations development and different universities around the world. I run workshops and work with them in the area of innovation, helping both their people that work for them, their staff, and students and external people to be more creative and innovative in their specific areas. So we do workshops, we do a whole host of different things with a company that I run, founded last year with a friend of mine called Sapient Innovation, and we do innovative work in there. So one of the main things I worked on over the years is, when I was still in university, I started a non-profit called the Rapid Foundation. And what that does is, the Rapid Foundation, we started it a few years ago, and the idea was we had access to 3D printers, and we said these can do an awful lot of good in the world. So we looked at how we could use 3D printers to do overseas development work. So for the last couple of years, we've been sending 3D printers to developing regions around the world. Like, these photographs are from Kenya and rural India, Uganda. So we send technology, we teach people and kids there how to use it, and then we support them using 3D printers to make the things they need. So it could be educational tools, it could be maps of India, it could be low-cost medical devices like these wrist braces, anything and everything, we help them do it. And then similarly, we do the same here in Ireland. So we go to technology events and like large kind of public events, like Dublin Maker Fair, environmental kind of sustainability events, and we show people what you can do with 3D printing and how you can use innovation, 3D printing, creativity, and engineering to solve global problems like plastic waste or access to information and materials. And then, they're very engaging. Our stuff is really engaging. We do workshops with kids, we do workshops with large corporations. So one day we could be doing a workshop with this guy here and helping him build little model prosthetic hands so he can relate to another kid of his age that needs to use a prosthetic. And the day after that, we could be doing a workshop with CEOs of large corporations. So again, wide range of scope, but I like to get all ends of the spectrum, and it keeps it interesting and keeps it varied. So one of the best things I've worked on in the past so far has been this. So for a long, long time, we were manufacturing 3D printed prosthetic hands here. This is me fitting one to a little girl, Ella. She was only 6. She was born without any fingers on her right hand, and it meant she couldn't use her arm, and she was kind of protecting it and keeping it away. So very, very quickly, I think it was in 8 hours, and for like 10 or 20 euros, we were able to 3D print her a prosthetic hand and give her some function back into that hand. And then, using a small amount of time, a small amount of money, and a consumer 3D printer like you'd have in a library or having a school, we were able to make these 3D printed prosthetics and make a big difference to her life and her family. So that journey brought me on a convoluted path, and with work like that, having such a big impact on people around the world, resulted in us winning, me and my co-founder winning an awful lot of awards. So things like research awards, outstanding people, and these awards were great because they helped us promote the work we were doing, but also gave me access to great opportunities and opportunities I could never have imagined. And particularly as an engineer, stuff you'd never assume an engineer would ever be able to get involved in. So, example, I was on the Forbes Under 30 list one year, and that's resulted in a load of different interested experiences. I get to go to their conferences every year. There's a conference, hopefully I can get to, COVID dependent, this year in Botswana in Africa in December. So, we get to travel, we get to work with company CEOs, co-founders, and meet really interesting people and create new interesting projects. I was also a brand ambassador for Nissan for 2 years, and they supported the charity, and, they provided a great help and with technology, and we worked on some technology projects. This was doing some mapping with drones along the west coast of Ireland, where we were trying to create 3D models of the coast in Ireland. I got to meet some really interesting people. The guy in the pink shirt is one of the co-founders of Reddit. And then Chris Hadfield, the astronaut, we get to have conversations. I talked to Chris for about an hour about old American muscle cars. You get to connect and have really good, interesting experiences. He was a mechanical engineer, so was I. We got on really well over a shared love of engineering. So it was great opportunities and great experiences. I had an opportunity to do a TED Talk here in UCD a few years ago about open innovation and innovation being available and open to everybody. And even now, the way I do workshops is not normal. They're very open. As you can see, there's no suits, there's no ties, there's nobody sitting in an office. They're all very bright and colourful and engaging, different ages, different kind of people from different backgrounds. I like running these kind of really fluid, interesting, open engagements. So during COVID as well, so this innovation potential means that I was able to pivot into new ideas. And probably about 2 months ago, to respond to COVID, I set up an organization called Open Source Ventilator. That then turned into a group called Team OSV. And what that was about 6,000 or 7,000 people volunteered online in the space of a week, who all wanted to contribute and create things to help support innovation. So first of all, we were looking at manufacturing ventilators, 3D printed cheap ventilators. And then secondary to that, we started looking at other things. So things like face shields, face masks, education materials. So over the course of the last month, we've manufactured an awful lot of things, got involved in creating very, very complex structures and systems, and then things like this. So these are just a small sample of some of the ventilator concepts we managed to develop. We went through 15 concepts, and 2 of them now have very high potential. Thankfully, they're not needed now at the minute, but they will be needed again in the future. So development will keep going. And via online, very, very quickly, we were able to make, all of these innovation and potential. So that was a very disruptive action in itself. So what I want to talk to you a little bit about is disruptive innovation. So the term disruptive innovation is an innovation that creates a brand new market and brand new value that wasn't there before. So things that quickly disrupt markets. So for a very basic example, the invention of the car disrupted the horse industry, or the horse and cart industry. That sort of stuff. The invention of the internet, you could argue is slowly starting to replace television, that sort of stuff. So it's new inventions to come along and completely change how society does things, or how industry does things in particular. So there's a huge whole host of these, and you're very lucky to live in the time in which there's so much technology, and there's new technology coming every single day. So on this graph here, this is the second horizon. So this is a horizon of disruptive technology. So these are the things that are very, very likely to completely change how we live on the now, in the medium term, and on the longer term. So things like precise manufacturing, digital currencies, augmented reality, these things present huge opportunities. And if you go on to study engineering, it wouldn't surprise me if you end up working in these fields that currently are very small or don't exist at all. And then you can be leaders in that field and help create the new industry and the new normal, all using this idea of innovation and creating new. So what I'm going to do is give you a couple of hints, give you a couple of kind of indicators on what sort of stuff is going to be very important for you guys when you go forward. And then, hopefully you'll get some ideas and you might be interested in working in that field in general. So one of the things is blockchain. So everyone's heard of Bitcoin and cryptocurrency. Blockchain is basically like a digital record book that records transactions. So blockchain is going to be super, super useful, and it's going to be one of the core elements of like data security, internet security, financial security in the future. It's a book. It's basically like a log which tracks all of the transactions that go on in it. So for security, for traceability, for trackability, it's excellent. So blockchain is a great idea, but it hasn't been fully applied to financial services or social media or anything yet. So there's huge potential opportunities in here for you guys to work on and develop and kind of create the new kind of base for transactions in the world. And then similarly to that is mobile banking. So traditionally a bank, you'd go in, you'd fill out a slip, you'd give them the money, it'd be lodged into your bank account, and vice versa. Whereas now most people have a Revolut card. Go to the US, most people use Venmo to digitally send each other money via their phones. And then if you go to a place like China, people pay for everything with their phone. You contactless tap your phone, which has your bank account on it, and you pay for things. So this idea of mobile banking, like me personally, I've not been inside the door of a bank for about 3 years. Everything is done via online banking or with my Revolut card. That's exactly how you work. And there's huge opportunities in changing the traditional banking system into this new banking system for you guys and us to use with this like mobile banking infrastructure. Similarly, fintech. So fintech is this idea of financial technology. So again, the financial world is quite old school, but brand new ideas, digital storage, online share portfolios, being able to buy options and trade on your mobile phone, applications to help you save your money, to track your money, that sort of stuff. Fintech is going to be huge as technology further connects itself in the field of finance and how it's going to relate to companies and into daily life. Similarly, the idea of social commerce is very, very interesting and is going to become way more popular. So on a base level, things like Done Deal, that's social commerce, one normal person selling something else to somebody else. But if you go to another country, an awful lot of countries in Africa, WeChat in China or WhatsApp in Africa, these are communication platforms, but they're doing sales through them. So one of the biggest marketplaces in all of Africa is WhatsApp. People creating these community shared groups and posting up something for sale in a WhatsApp group chat with 10,000 people in it, and then somebody saying, I love that, I'll buy it. So social commerce, new platforms, new opportunities is going to be very, very interesting and cause an awful lot of trouble for both online commerce and then normal stores and shops. Then similarly, real estate. If you take COVID now, if you want to buy a house, you can't get in and view it because it's unsafe. So people are doing like video call viewings. That's going to probably become way more popular. And the process of buying a house, you probably want to buy it online. I buy most of my things online. If I can afford it, I can't see why I wouldn't buy a house online. But there's systems that need to change and architectures and new opportunities and new companies that need to improve so this can happen. Then similarly, remote working. So everyone has heard about WeWork and these satellite offices. They're very, very, very of the moment now because nobody knows whether you should be working in an office anymore. And the majority of the world is working from home now. So there's going to be huge new opportunities, making working from home as good as it could be, improving it, creating new systems, helping people connect and relax and feel part of a team while being separate from each other. So there's huge opportunities in that. And again, live sports. So again, at the minute, live sports aren't running. You can't go and view it because of Corona. But even in the future, will people want to? So esports, things like Twitch and, whether you're streaming Call of Duty online, that is becoming as popular as the Premier League. So there's huge opportunities here in new sports, new ideas and remote kind of sports streaming online. Then you're probably at the right age to see the first kind of commercialized space travel. So Elon Musk, Dragon, SpaceX, people that are going to try and start colonizing other planets, more efficient, more regular transport to the moon, or Elon Musk trying to put people on Mars. This colonization brings whole new problems, but also whole new opportunities, new things that you guys can work in. And engineering is going to explode in this space sector over the next couple of years, and it's really kind of exciting. And then on a more kind of localized level, water rights and distribution is going to be very important. Water is the most useful, important commodity in the world. Super valuable, super important, but not everyone has access to it. So the technology in cleaning the water, in sourcing the water, making sure it's distributed quickly, making sure there's new water systems created for places like Africa and the Middle East, which is very hot, have a lack of water. So there's huge amounts of opportunity in here. And water is going to become one of the most valuable commodities in the future because everyone needs it. And then how that's delivered is also a problem. We create so much waste plastic, waste packaging, waste in general. So we've generated all of this. What do we do with it now? Is it recycled? Do we break it down? Do we turn it into new plastic and use it again? There's huge amounts of opportunity in packaging. So there's lots of issues in there. And that's probably one of the growing fields in engineering. If you guys study it in the future, it's what we do with the waste, how we recycle it, and how we become more efficient using materials. Food and nutrition is very important. So, farming is very intensive on the environment, land intensive, water intensive, emission intensive. So things like Impossible Burgers, meatless meat, or companies like Nuritas who use computer science to find useful, nutrients in food. And then the issues with solving and feeding the third world. So things like plumpy nut butter, peanut butter, high quality, high protein and high kind of calorie stuff to feed the growing number of hungry people in the world. And then related to that is agronomy. So this is insect farming. So, protein is hard, cows are expensive. Insect farming is going to become more and more popular. I've eaten them before. They taste fine with chili sauce on them, so you'd be grand. So growing and the large culturing of farm insects for food and protein is going to become way more popular and important. So there's lots of issues there. And then, of course, energy and sanitation, particularly now. More of the world needs energy. We need renewable energy. We need solar energy. And more people need sanitation, toilets, hand washing, that sort of stuff to keep them safe during global pandemics, but even just beforehand. So more people in the world died from poor sanitation than have ever died of COVID or any form of other infectious disease. It is a big world problem, and it's a problem and a challenge that needs to kind of be solved. So what other ideas do you have? Have a think about them. What is the new fields that are going to happen? What is the new interest in the new areas you would like to work on? And where do you think your career is going to go in the future? So that's a quick little taste of my background of some of the areas I'm going to be looking at and some of the fields I think you guys are going to look at in the future. So I hope you're enjoying your little taste of engineering, and I hope to see us all as engineers again in the future soon. Thank you very much.
Great, thanks to Colin for putting that together for us. Our next sample lecture that we have today is Dr. Philip Donlan. So I'm just going to get Philip with us now. And he's going to give us a talk on renewable energies. And Philip is from our School of Chemical and Bioprocess Engineering.
Can you see my screen?
Yeah.
We're good to go. Okay. So hi everyone, my name is Philip Donlan. I'm a lecturer in the School of Chemical and Bioprocess Engineering. And the sample lecture I'm going to give you today is on this idea of renewable energy. I suppose I want to kind of maybe approach renewable energy maybe from the perspective of an engineering perspective. So we know it's obviously a very hot topic. It's something that realistically requires no introduction to us. We know that we're in a race against time. It's a race which, unfortunately, at the moment, we don't seem to be winning. So we know that we need to act fast, and it's something that's it's very topical at the moment. It's in the news all the time, and rightly so. And so the trick is, as an engineer, what kind of contributing actions can you take? What can we do in order to make sure that we have a future which we're all comfortable living in and our kids to live in? So that's what I'm going to talk to you about today. It'll be kind of reasonably high level. But again, all of these things are things which you go into a lot more detail throughout an engineering degree and obviously through your engineering career afterwards. So just, I suppose, as an introductory point, we won't harbor too long on it, just having a quick look at a typical type of overview as to where energy comes from. And I suppose the message we're getting from this is that the majority of our energy comes from fossil fuels. So here we have natural gas, we have coal, we have peat, and you can see that renewables is only a small little portion here at the top. And for us to be sustainable, we know that basically we need to be using renewables. In other words, we need to be using energy sources which are not contributing net carbon dioxide emissions into the atmosphere. And so the question then arises to say, well, ultimately we all were familiar with renewable sources such as solar, wind, etc. One of the questions is, why are we not using them? And that's something we're just going to quickly talk about today. And that's the real challenge as an engineer. We know the technology exists. What do we have to do to actually make it happen, make it a reality as part of our everyday life? So first things first, let's give a quick overview as to where we actually get our energy from. So this is the bit that we're most familiar with when it comes to renewable energy. We're most familiar with seeing solar panels or wind turbines, etc. So just first of all, really important just to understand what's going on, what maybe innovations are taking place in that sphere of things. So first of all, looking at solar energy, again, something we might be familiar with, but basically what we have here on the left-hand side is we have a typical solar panel. And what happens is our solar rays, so the rays from the sun come down, they hit the solar panel, and typically, or traditionally, if you like, these have been made of silicone layers, so different silicone layers. And when the sunlight hits our panel, as we have down here on the bottom right-hand side, what happens is the electrons within these silicone layers are released and are able to kind of travel. And then what happens is they travel in a particular way, as we have in our diagram here, so as to form a circuit. And whenever you have a circuit of flowing electrons, that means essentially we have electric current, which is what we want. So what we've essentially done is we've taken energy coming from the sun and we've turned it into electricity, which we can use in our homes. So what's the exciting thing about solar? Well, first of all, as much as sometimes in Ireland it's not that obvious, but ultimately the sun delivers more energy in an hour than is needed worldwide in a year. That's an amazing statistic. Okay, we are talking on the previous slide, we were talking about how much we still rely on fossil fuels and other sources such as this. But at the end of the day, if we can see that in 1 hour, we can get as much energy as we need in a year, then it really begs that question as to why are we not actually doing this? Why is that not something that's going on at the moment? Well, I suppose one of the primary obstacles from a solar energy perspective is the fact that traditionally they have looked very much like the panels here on the bottom. So they've been rigid and expensive to produce, if you like. So it contains a lot of silicone, it contains a lot of glass, and it contains a lot of material, if you like, that ultimately just simply isn't cheap to actually produce. So what that means is then if you're trying to install silicone in your home, you end up looking at a bill of potentially a couple of €1,000, which can obviously be a big deterrent. So from an innovation perspective, from an engineer, where's the challenge is that we need to overcome that problem. And one of the ways we do that is, well, one of the ways which is ongoing at the moment, in many ways, is try and say, well, if the problem is expense and rigidity, that we need big fields like this in order to have enough surface area, well, can we make them small and flexible? Can we make them cheap? So you can see here on the bottom right-hand side, the move is towards trying to make these film solar collectors. And just showing you what can be done with that. Here we can see a roof in Scandinavia where someone has taken their roof and they've actually integrated these thin films of solar collectors, these photovoltaic cells, into the actual structure of the roof itself. So what that means is now you're taking up no extra area. You just simply have your house, but ultimately your house is now producing electricity. Remember, all it's doing is collecting electricity and energy that is naturally available to it. So it's a fantastic way to use what we already have in order to produce what we really need. So again, from an engineering perspective, how can we turn a large area, expensive situation like we have at the bottom right into a small area, cheap solution like what we have here on the top of the roof? So that's a really, really tough engineering challenge and one which is ongoing because obviously very hard to do it in a film situation versus in a static plate like that. Other sources of energy which we could be using, especially in Ireland, a really obvious one is tidal and wave energy. Now this is a much more developing technology, one which isn't as far along as solar. So basically here, just again looking at our diagram, we can see that we have an example of tidal energy where we know that the tide moves in and out throughout the day. So we know that there's this huge volume of water which is moving backwards and forwards. And whenever you have something that's moving backwards and forwards, you can think, well, how can I try capture some of that energy which it has and turn it to electricity? So in our diagram here, or in our picture, what you can see is you can have the tide, which is probably in this case moving, say, from right to left. And what you can see in the way of that tide, we've put these type of turbines. So as the water is moving through the turbines, it's turning them. And again, that turning motion is producing electricity. Again, where's the exciting bit from an engineering perspective? One, it's still a developing technology. So it's not still at that level of development as we have with solar energy. A lot of people wouldn't be as familiar with this. It's not as widely used. But ultimately looking at, say, Ireland, we can see that, again, not so much interested in the actual numbers here, but more the magnitude of them. We can see that we have about 525 terawatts of terawatt hours of available such tidal energy in Ireland. But electrical requirement in 2018 was only about 30 terawatt hours, which means that, again, we have multiples more than we need. Where we need to be as an engineering community is how can we get our technology to the point where we can harvest all of this required energy or this available energy in order to produce the much lesser required amount which we have. So again, huge availability there, huge engineering challenge to actually capture it and make it a reality. Again, here we just have some more examples of wave energy. So waves obviously are a great source of energy in the fact that waves move up and down. So as the top of the water is moving up and down, what we can have is these kind of cylindrical objects. And as these cylindrical objects are not hard fastened to each other, they're going to move up and down with the waves at different rates. So as the cylinders are moving up and down, they're moving relative to one another. And that motion against each other allows us to actually produce electricity. So we're able to capture that compressive motion which is taking place between the cylinders as they're bobbing up and down on the waves in order to produce electricity. So again, a huge amount of research going on here. Again, we're surrounded by waves in Ireland. Huge opportunity for us to collect some of that energy. And anyone who's ever stood in the sea will know the power that exists in that water. When a wave hits you, it really does have a lot of energy. So that's what we're trying to capture here. So again, not many of us see this everywhere in our everyday lives. showing that there still is a huge engineering challenge to get these to commercially ready systems. Wind energy is one that we do see a lot of in Ireland, and again, it is a good source of energy for us in Ireland because, again, being an island, we do have a lot of wind, but again, there's other problems that come with wind, and the fact that there's often been a lot of public objections in terms of maybe not wanting the wind farm close to residential areas, etc. So as an engineer, there's all sorts of new challenges there. So yes, now we know how wind turbine works, but again, how can we make wind turbines which live symbiotically to us as people and also make economic sense? So looking at this example here, this is where we have offshore wind turbines. And again, this is the idea of where you take the wind turbine, which people don't want near their residential setting, and move it out offshore where basically no one lives. And again, what that is, it reduces that problem. Again, you can't ever eliminate it because they still will be visible. But again, you're reducing the problem which is associated with this technology. But of course, the problem that you're solving might potentially generate a new problem, which is the fact that it's much more expensive to have wind turbines out offshore. So again, from an engineering perspective, the challenge is maybe not so much trying to understand how we can capture wind energy, because we can see we can capture it, but how can we do it in this way and make it economically viable? Huge challenge, not to be underestimated, but it is probably one of the big challenges with wind energy. Okay, so that's a kind of a bit of a rundown as to the ways that we know that we can generate renewable energy. But I still ask the question, so if that is all of these fantastic ways which we can generate renewable energy, why are we still using fossil fuels? Why are we digging things out of the ground when we say that we have more solar energy in an hour than we need? If we have all of this wind energy available to us offshore, and again, we have all this wave and tidal energy as well, just to name a few. And the reality is that a lot of it comes down to supply and demand. So again, if we look at a day here, a typical day, right, we can see here that during the middle of the day, there might be a lot of sun, like on a day like today, there might be a lot of sun, but again, during the middle of the day, a lot of people might be at work, they might be out of the house because it's sunny, they might be outside, which means that the electrical requirement might be quite low. So there's not many people have electrical appliances on, but there's a huge abundance of solar energy available. But then later on, the sun goes down and everyone comes inside. So there's a huge requirement for electrical energy and obviously an almost zero supply of solar energy. So we can't always balance what we need with what we have at the exact time of day. And here's another example of seasonally how that can happen, where during the summer you have loads of solar energy, but ultimately the demand might be low, whereas in the winter, longer days where it's dark, if you like, and of course shorter sunlight hours, so again very hard to balance the two. So supply and demand is the problem with renewable energy. Okay, well, supply and demand is the problem, why don't we store it? Well, the problem with storing energy is the fact that it's not a physical object. So again, I can't hand you energy, well, not in as many words, I can't hand you something that you would recognize as energy. It's not a physical object, so how do you store something that you can't feel in a way that you can't feel, touch, or if you like, put in a bottle? Well, as an engineer, this is our challenge now, because we know that we can produce it, and there's challenges associated with producing it still, of course. We know the problem is the fact that we just need to be able to produce it at the time when we need it. So we now shift our attention as an engineer to saying, well, okay, can I figure out an innovative way of actually storing it? Okay. Most obvious way is the way that we do every single day. So all of our phones are energy storage devices. So our battery is an energy storage device, okay? You charge in the morning, use it for during the day, and then you might charge it again in the evening. So you charge it when you have electricity, when you're beside the socket. You use it when you don't have electricity, when you're out and about, and then you charge it later on when you're back to the electrical, when you have a socket available to you again. So again, works perfect, and obviously is the obvious choice in terms of how we would store renewable energy. The problem is, if anyone's ever bought a replacement battery for their phone, they know that that's not cheap, and that's for your phone, which can hold a small amount of electricity for a couple of hours. But that wouldn't even come close to understanding how expensive it would be to hold all of Ireland's electricity for an entire day or a week or a month or even a year. So the expense is one of the big problems. And of course it uses materials, the traditional battery will use materials such as lithium, etc., which obviously are finite resources as well. But so if we know our batteries are very expensive, we need to produce different batteries. And again, there are different batteries being produced, such as flow batteries, etc. But I suppose the one main thing we're taking out of this is that we have a challenge to store energy in a way which is accessible to us, which is safe, and which is cheap enough for us to actually do on a large scale. So a way in which we've been storing energy in a way for hundreds of years is using pumped hydrodynamic energy. Now, we've been using traditional hydroelectric dams, etc., such as in Crusher in Ireland or in the Hoover Dam over in the United States to store energy for hundreds of years. And how that works is basically we build a big dam and we store the water at a high level, such as on the right-hand side of the diagram. And then what we can do is we can allow that water level to build up. And of course, we know if water level builds up and you release a little valve at the bottom, it's going to shoot through to the other side, isn't it? And that shooting through allows us to turn a turbine. So if we take that idea of the hydroelectric storage, right, and try to see how can we adapt that idea to what we currently need. The problem with this is that you need geographical locations where you can actually set up a big dam. We know setting up a dam is not cheap, but an alternative way where we can control it a little bit more is where we say, imagine if we had the sea, such as down here on our diagram on the right-hand side, and we took a pump, and then we had a high reservoir, such as a big tank or a valley or something that's at a high level. And when we have electricity, right, what we'll do is we'll pump it up to a high level, and then when we need that electricity again, so during the day when we have solar, we use the solar energy to pump energy up. And then at night, when we need that electricity again, and there's no solar, what we can do is we can allow that energy to flow back down again, turn a turbine, and produce electricity. So that way we can turn on the pump when we have electricity to store it, and we store it in the form of this water being stored at this high level, and basically open a valve then when we need the electricity and get it to turn the generator to produce our electricity. So that's one way of doing it. Again, problems with that are the fact that we again need that high reservoir, which isn't always readily available, and we've probably exhausted a lot of those opportunities already in terms of places we can store all that water. Another way of doing it is take this idea that instead of pumping up to a really high level, could we pump it into like a really high pressure vessel? So look at this poor gentleman here pumping up the tire. Imagine if he put all the effort into pumping up that tire. He's putting energy in, and then we came along, we burst that tire, we'd be releasing that energy out again. So we'd put it in when we have our gentleman to do it here, and we release it when we need to, basically when we put that pin into our balloon. And this is called compressed air energy storage. And again, the way it works is during the day when we have electricity, we use it to compress air, to pump air down to this really high pressure vessel, if you like, or cavern underneath the ground. And then when we need electricity, we can open a valve here, release that really high pressure energy, get it to turn a turbine and to produce our electricity again. So the same idea as pumped hydro, but again, we're just making it a little bit more controlled. We're no longer needing the really high area, the really high location, if you like, the valley or the high reservoir. We can now just pump it into a tank underground. The problems with this, of course, is the fact that it is still requires really, really high pressures and still requires a lot of space. So it's still expensive and pretty tricky to do. And then the last one, which I'm just going to talk to you about, is this idea of hydrogen energy storage. Again, it's something that people have heard a lot about. And it's this idea that in our, I suppose, school science curricula, we would have learned about electrolysis of water. So basically, if you pass a current through water, you will essentially be able to, or if you like, if you put two charged electrodes into water, you'll be able to split water into hydrogen and oxygen. When you have hydrogen and oxygen, you can separate them. So we produce hydrogen here on the left, oxygen on the right, and we can store those in separate tanks. And then when we need to produce energy again, what we can do is we can take the hydrogen, we can burn it in the oxygen to produce our energy. The beauty of that is we're splitting water here using electricity to produce hydrogen and oxygen. And then when we burn hydrogen and oxygen, we're going to produce electricity once more. And the only byproduct of that will be the water again. So it's a perfect cycle. Again, the trouble with this is that we're dealing with hydrogen, we're dealing with oxygen. Again, so that's a very combustible mixture. Very, again, still deemed pretty expensive and pretty dangerous. So the engineering challenge is how can we do this in a way that allows us to do it in a safe, small, economically viable manner, such that houses, cars, or even city districts, if you like, can have these units in a really safe and commercially viable manner. So look, I suppose what I've kind of shown you is just a really high overview of maybe some of the ways in which we can produce electricity in a renewable manner. And the other side of it is, yes, we know that there's a huge amount of availability there. So there's an engineering challenge to capture it a little bit better, if you like, more economically feasible, so we can all do it. But then the real challenge is how do we store renewable energy? And that's one where, again, just showing you a couple of examples, but I suppose I'd ask you, like, how can we improve upon this? Is there any way which we haven't thought of that we can do it? Is there an improvement to what I've shown you that we can come up with? And that's the engineering challenge at the moment. That's what we're all working on. And that's a really, really exciting challenge. And again, if you do decide to do engineering in UCD, you'll get plenty of opportunities to work on things like this. And if you decide that you'd like to make a career out of it as well, there is no end to these opportunities in terms of what an engineer can do. It's one of our biggest challenges in the world. And it's one that we are still really, really trying to overcome. So I hope this has been useful. Delighted to take any questions as they come at any point. And I hope to see you in UCD.
Thank you very much, Philip. Actually, we just had one or two questions specifically around when you were giving your presentation, if you don't mind answering them.
No problem at all.
Yeah, so they're just around there in the chat. So how long is the lifespan of the panels, and also is the disposable of the panels clean?
So again, what I'd say there is it very much depends on what technology we're looking at, okay? So one of the main kind of, the main things I was talking about with the panels is traditionally there have been these kind of rigid silicone panels. So again, yes, of course, we'd want to kind of recycle those. In terms of the films, there's no standard set film technology which is being used everywhere at this point. That's what I suppose we're trying to get to at the moment. The rate at which energy is captured off those is still less than what we have off the rigid solar panels, so they're not maybe quite as widely used. So in terms of like the recycling opportunities and all those, they'll be developing symbiotically along with them. So I suppose my perspective on that would be, because that is still a developing technology, really, really important things like what you just talked about there, they'll happen in conjunction with it then as we go. So the first thing will obviously be getting the actual technology to the point where we can all have it in our homes or in our kind of business or where it happens to be. And then alongside that, then over the years, as they need replacing, what happens is symbiotic businesses and technologies tend to emerge which develop technologies to do the recycling, but no reason why we can't recycle everything. That's going to be developed alongside the technology then as well.
Okay, great. And then there was just another one as well around the introduction of natural resources into the sea and the effect on marine life and how disconnected during rough seas and things like that.
Yeah, so like I suppose like the one that was connected with the sea there primarily was the pumped hydro storage, I'd imagine, right? So that's where again we were taking the water out of the sea and putting it back in. I suppose the way I'd see it is like in theory, nothing should really be happening in that cycle that should drastically affect the marine life. Now, I'd have to put my hand up and say I'm not a marine biologist, so there's probably someone who can correct me on that. But from a kind of a high level perspective, we're doing nothing to that water except take and putting it back in again. And the process of taking it out requires energy. So it's almost like kind of lifting a bucket of water out of there is going to require you to put in energy. Then you have that bucket, you can hold it, and then you can pour it back in again whenever you choose to release that energy once more. So again, all we're doing is that. So we'll be taking out, putting into kind of a concrete reservoir, or potentially if there's a natural valley or lake that we can use, and putting it back in. The marine biology side would be hugely, hugely important. Nothing should be happening at that point. We shouldn't be affecting the water in any way really during that process. It should just be more that we're moving it from one place and then putting it back in again, but we should not be affecting any species or anything in it.
Okay, great. And then I think we have time for one more for you, Philip, before we move on to our Q&A with our students. Is nuclear energy still being considered and developed, or are we moving into a phase of newer energy resources instead?
Well, I suppose nuclear is one where you'll have a lot of different opinions. So it's not, I wouldn't say it's as clean cut as saying it is either being considered or not. It's more, I suppose, is it some part of the bigger picture as we move forward? Across the world, nuclear is still very much being developed. It's never been a large part of what we do here in Ireland, but it is still very much developed across the world. Just to throw one, I suppose, one part that I think is really interesting, and someone who is interested in energy, there's different types of nuclear energy. Nuclear fission, which is, I'm sure what our question was referring to. And then we have also nuclear fusion, which is obviously a much more kind of futuristic way of producing energy, which is where we're actually taking deuterium, which is available in the sea. It's basically a version of water, which we can basically convert into, and basically what happens there then is we release multiples more energy than we currently do using the standard nuclear fission approach. And so I suppose where I look at it is like nuclear fusion is not nuclear fusion is obviously futuristic, and that's something that someone who's interested in what, like, say 50 years time or 100 years time might look like, I'd always say have a look at that, because that's just exciting, right? And there's some really, really cool stuff happening there. And there's a pilot plant being built in France at the moment. There's also a pilot plant, a smaller pilot plant in the UK, where people, again, who are interested can go over and visit. You can actually stand in this nuclear fusion reactor, which during operation goes up to 200 million degrees Celsius. So if anyone wants to experience a cold version of that, that's always good. Nuclear fission, then, the way I'd see it is, again, it's, I suppose, maybe not, it's not a fully renewable technology, but it might be something which, as part of a roadmap towards renewable, might help us reduce CO2 emissions. It has other problems with it, such as waste disposal, but again, that's more on a country-specific basis whether people are including that. We traditionally haven't, but other countries are.
Great, thanks, Philip. I think we'll move on to our Q&A now with our students, because we're running out of time. But thank you very much, Philip, for helping us out today and answering those questions as well.
Delighted. Thank you very much.
No problem. Right, so I'm just going to promote my students now to our panel, and then we can get started with the questions that you've been answering in the using the Q&A button at the bottom of your screen. So we have Connor Flannery, who's our structural engineering with architecture student, and he's just finishing his 4th year. And then we also have Niamh O'Connell, who is just finished her 3rd year in chemical and bioprocess engineering. So let me just get them on with us. Hi, Connor.
Hey, Laura.
Hello.
Right, so we have both of them here. So we've got a good few questions in now. So if anyone wants to type any more questions to us, just use the Q&A button on the control panel on your bottom, and we'll start answering those for you. The first one that kind of came in was about internships. So Connor, I know you're on your internship placement at the moment. If you want to maybe talk to us a little bit about how you've been doing or that kind of experience.
Yeah, so in UCD in 4th year, students do an internship, and essentially UCD organise companies so that you can apply straight to companies through the UCD website. There's usually loads of companies. If you don't want to apply straight to those companies, you can contact companies yourself. For example, I applied to a company in Scotland, and because UCD is so well recognised, they just did a quick phone interview, and I was able to come over to Scotland in January and start my internship. And it just gives you a good way of experiencing the actual working world in engineering. There's so many different internships you can do depending on your stream, and yeah, it's just really good. And most of them are paid as well, which is a kind of nice bonus.
Great. And just following that, most of our students do get paid for their internships. Obviously, we can't guarantee that. It's up to the company if and how much, but most of the companies really, really value getting students on board for these internships, so they do tend to pay them, which is really good. Great opportunity for the students. Another question was around how many hours would you spend in your particular course? Maybe you could talk about what a typical week would look like. Niamh, if you want to start.
Yeah. So in 1st year, it's quite a lot of hours, which actually helps quite a lot from going from the secondary school environment to university. I know some of the other subjects wouldn't have as many contact hours, but we'd typically be in maybe 9 to 4, 10 to 5. Now you'd have breaks, like maybe 2 hours in the middle of the day, or you might have an hour break here and there, but it typically would be pretty full on with between lectures and then also your labs. So you might have maybe 2 labs a week, which could be an hour or 2 hours even, and then you'll also have your lectures and your tutorials. So it would you could expect to be in college maybe 9 or 10 till 4 or around then, but then with breaks in the middle, and then you can obviously meet up with your friends or get food or go to the library during those breaks and stuff as well.
Great. And Connor, what was your kind of week looking like?
Yeah, so similar to Niamh, and as Niamh said, in 1st year it's quite like you're quite busy with lectures and labs. As the years go on, you kind of have less lecture time, but more maybe assignments or project tasks to work with. So you are kind of, you know, you're usually on campus Monday to Friday for a lot of the day. And as Neve said, plenty of breaks and plenty of lunch breaks to keep your mind fresh. But I think as well, like, you know, it's a really rewarding degree, and it's not necessarily going to be easy or not going to be, you know, little hours to do. So the amount of hours you put in, you do get a lot out of it, and you know, you're constantly doing assignments and you're keeping on top of the material, which is a good thing.
Great. And then obviously you're both doing two different types of engineering, two very different streams of engineering. And that your engineering stream is particularly creative, or would you think some of the other streams of engineering might be a bit more creative?
For myself, is that?
Yeah.
Yeah. So yeah, well, I guess like that was one of the reasons I chose structural engineering. And similarly, civil engineering, it's a bit more engineering that you can see and touch, and UCD is very good at having practical assignments. And in UCD, there's a big work lab where you can do timber work or steel work, and it kind of links in with your degree and the theory you've been learning. So I do think it's a creative in the kind of physical touching element, but I think every stream of engineering, which Neve will probably tell me, has their creative elements to it.
Yeah, I wouldn't say it would be your typical idea of creativity, or like, say I'm studying chemical engineering, so it wouldn't be as tangible, but we do a lot of project work. So every semester for chemical engineering now, I had 2 big group projects. This semester, a design project, and it was kind of a design project as well. So that's almost creative in that, because you're working as a group to come up with a solution to a final problem, and there's no straight path or no set design. So you're kind of creative in how you're coming up with ideas or taking from different sources. So I would still say it's kind of creative in that matter, and like you're encouraged to think outside the box and bring new things in. So it wouldn't, for chemical engineering, it wouldn't be so much in the physical sense, but like they encourage creative thinking and thinking outside the box and bringing in new ideas too.
Yeah, I think that's an important point as well. Like in the Leaving Cert, you're kind of taught how to answer specific problems, whereas within engineering, you know, the problem solving aspect has to be creative in order to be kind of efficient.
And just following on, Connor, you were just saying about the Leaving Cert, do you find that the step up to going to do engineering in college is quite different from the Leaving Cert structure, and maybe the subjects that you did for the Leaving Cert, whether they were covered or you found you were lacking in an area based on what you did choose for the Leaving Cert?
Yeah, so for myself, I did physics and of course higher maths, I suppose, in terms of engineering. So I didn't do applied maths, I didn't do kind of any other engineering related modules or subjects, but the main thing you have to know is not everyone's going to have the same thing coming in. Some students will have a lot of sciences, but they mightn't have applied maths, and that could be the other way around for other students. And the good thing about UCD is they kind of, for the first week or two, they kind of do a revision of the end of the Leaving Cert, and they just kind of move on from that point. So I know students, I think someone asked about biology maybe. I've known students who've come in without biology and without physics and without applied maths, but they've done biomedical engineering. They might have to put their head down for a little bit to study hard, but you know, everyone will have their kind of weaker and stronger points, and that's what first year is about. It's kind of catching everyone up, letting you work on areas that you're, you know, maybe not as up to date with, and it's not really, once you put your head down to kind of learn those areas, it's not a huge problem.
Yeah, I kind of agree with Connor, and also like the style of teaching is different. You're going from a classroom with maybe 30 students to a lecture hall, and some of them could have 300 students at the same time. So it does take a little bit of adjustment, but I will say the lectures are extremely helpful, and they try and make that transition as easy as possible for you. You'll also have tutorials, so that would be a smaller class where it's easier for you to ask questions directly to the TA that's running that tutorial, and then you'll also have labs and stuff too. So it's kind of different, and it takes a little bit of getting adjusted to, but the lectures really do try and make it as easy as possible, and there's a lot of different resources to help you along the way with it.
Right, and then for both, were you looking at other universities to go to, or did you only want to go to UCD, and how did you make that decision?
So yeah, I was looking, I wanted to keep my options open as much as possible, and I kind of had that going in. I looked at a lot of the different universities, but I kind of knew I wanted to do engineering. Initially it was between science and engineering, and I decided engineering was where I wanted to go. And then what led me to UCD in the end was just the variety of choice. You're not limiting yourself. The general first year was a huge appeal to me. I didn't want to, it's so hard to know what you're doing, even picking your subjects for leaving cert, which you're probably doing now. It's so hard to see where you finally end up. So the fact that it was a general first year and then the variety of options available after that first year is what really drew me to UCD in the end.
Yeah, and I'd agree with Eve. It was, you know, that it's nice to have one general year, you're not going straight in, or you're not having too many years in a general engineering. And as well, I liked, well, I am from Dublin, and UCD was quite closer to my house, which is obviously a factor. And then I do like the kind of single campus aspect of UCD, and it's all kind of within its own area and has all the facilities nearby. So that was kind of, you know, kind of my idea of college maybe. So that was a nice facility, I suppose.
And were you, any of you either thinking maybe doing science at one stage and then chose engineering, or do you know students in your years who maybe were wrestling between whether to do science or engineering?
I do know students that have kind of had a, you know, broad range of areas they want to go into, and like some students are more interested in computer science and they kind of take up more computer science areas within engineering because that's of course an option. And I guess, like, you know, you have students interested in all different areas, and I think that's the nice thing with engineering. You can kind of, while there's certain things laid out for you, you can kind of go towards aspects of engineering that you prefer. If it's kind of, you know, designing or the theory side of it, or the kind of even science experimental side.
Yeah, like I mentioned there, I was definitely weighing up between science or engineering, and then I kind of figured in the end, well, chemical engineering, I was definitely interested in that. I studied chemistry for the leaving cert, so I thought that might be a nice option. And I just liked, at the end of the day, the problem solving aspect of engineering, and kind of you're bringing in from your maths, your physics, your chemistry, you're bringing in different areas of science to come up with solutions to problems. And I liked that idea maybe more so than research, but then you can also, I've started to learn more and more and become more interested in engineering research and how that relates to science too. But I kind of knew I wanted to go into more the problem solving side of it, or like tangible solutions and processes and things like that.
Yeah, great. And then, students obviously may be interested in pursuing the full 5-year program with us and maybe wanting to do the masters. So we've had some students ask us about, you know, how do they specialize afterwards? So for most of our students, at the end of 3rd year is when they make that choice if they're going to do the 4-year or the 5-year program. And at that stage, you can also choose to specialize in your area a little bit further. So for instance, say if you're doing mechanical engineering at master's level, you can choose to do the likes of energy systems. You can just stay with mechanical engineering for your master's. There's engineering with business, there's material science and engineering. If you're doing maybe chemical and bioprocess engineering at undergraduate level, you've got a little bit less choice at master's level, but you know, you've still got a couple of choices. And the same if you're on the civil engineering or structural engineering path, you're probably going to stick with the civil engineering or structural path at that stage, but there's also the likes of engineering with business for our civil engineers as well. So yes, going to choose your master's options, you're a little bit kind of hampered by what you've chose for your undergraduate part, your discipline in 2nd year, but there are still choices available to help you specialize further if that's what you want to be able to do. And then obviously, Connor, you've chosen to go on to do the full 5-year program, and Niamh, have you made your you're going to do the full 5-year program?
Yeah, at the moment my name is down for it. We to decide back in April. I'm going to take a little bit more time over summer just to consider everything, but it does seem like a really beneficial master's program because you get that industry experience, which is quite important when looking for a job. So you have 6 months, or what a lot of chemical engineers end up doing is they do their research project in industry too. So you're spending 12 months in industry and you're doing your master's while there, and they're also paying you. So it's a really good position to be in, and it's to have that industry experience when you're graduating is really, really valuable. So at the moment, I'm thinking of doing it for sure. But I'll take some time over summer as well to consider it, because I think there is a little leeway there to change last minute.
Yeah, and then for students who are maybe wanting or have interests outside of their engineering and maybe wanted to take advantage of the UCD Horizons program, can you tell them a little bit about maybe what the subjects you studied outside of engineering, or whether you chose to do those Horizon modules from within engineering?
Well, I go, okay. So one of the ones which I did through Horizons second semester of second year was Swahili. So through UCD, I got involved with their Volunteers Overseas program, and then last summer I went to Tanzania for a month with UCD Volunteers Overseas, and we were teaching computer skills to secondary school teachers over there. So through Horizons, the semester before, I was able to take on the Swahili language elective module, and I knew nothing about the language before, but it was really interesting. It was really different from engineering, and it was super beneficial then going over to have the language, and they also taught us a bit about the culture as well. So I was really grateful to have that opportunity and to be able to study the language while in UCD, and to have it counting towards my degree as well. The academic credits still count towards your degree.
Yeah, and as well as that, UCD offer electives through the semesters. So you usually have one elective per semester, and it's just any module within the whole college that you can apply to be a part of, and you complete the module like anyone else completes it, and it goes towards your grading, and it's equally weighted to like an engineering module. So it's kind of nice, like a nice experience outside of engineering. For example, I've done psychology and geography modules, and I've also done like engineering design modules. So I guess they are related to engineering, but slightly outside of my stream. And of course, you can do modules within your stream to just get a further experience and knowledge. But it is a good idea to kind of take a break from engineering, maybe go to a different building for once in a while, and yeah, just kind of get a nice broad knowledge of things.
Yeah, I think it's really beneficial. Most first students find it very beneficial. And then a question around obviously when students are choosing their preference going into second year, are they guaranteed their first preference choice? And the simple answer is yes. For the most part, our students have never had an issue with, if they chose to do one particular stream, that they haven't been able to choose that. So essentially it is free choice. But I mean, if everyone in 1 year decided to do chemical engineering, for instance, the lab space couldn't accommodate everyone. But generally speaking, it does split fairly evenly, that we've never had an issue where someone chose to do one particular stream and wasn't able to do that. So essentially it is free choice for our students. And then just around, obviously students that are listening in today are Leaving Cert students for the most part.
Okay.
Do you find that going from Leaving Cert is quite different, or how you're taught is quite different, or the structure that, from the Leaving Cert is very different in university?
Yes, the structure is of course different. The kind of core aspects of, school, I suppose, still come through with that. You have to do your homework, you have to study, and then you have exams towards the end of the year. But I mean, aspects of flexibility, you're in lectures, theatres of 300 people. For example, I was in a boys' school, so there's obviously girls in the lecture. You have tutorials, which are in smaller groups. So there are different aspects of teaching through UCD, and they are definitely more beneficial, I think, anyway, compared to the kind of standardized teaching of school.
Yeah, and I think it is different, but there's definitely a lot of supports along the way. There's something that I found really useful in first year was the Maths Support Centre. So, for example, if you had you found the maths homework difficult or your maths assignment difficult, you couldn't really understand fully what the lecturer was going through. During his lecture, you could bring this material to the Maths Support Centre, and they won't do your homework for you, but they'll talk you through it and help give you an understanding of the material. And it's more a one-on-one. It's free to use. I think you can just walk in, or you can also make an appointment online. So I definitely use that in first year. They also have one for like computer science, because we have introductory coding modules as well. So I know a lot of my friends went to the Computer Science Support Centre too. So they have all the resources there to help bring you up to speed with the different style of teaching as well.
Yeah, I think UCD kind of has a nice working with each other environment as well. Like a lot of students help each other students out. You know, we were talking about subjects earlier. You might have a friend who maybe did physics and you mightn't have done physics, and you know, his quick, or like, you know, a simple kind of answer can save you time, and then you might be able to help him in chemistry or something later on. So it is kind of, it's a nice environment where students do definitely help each other as well. And sometimes they say, you know, peer learning is kind of best kind of learning. So
yeah, exactly.
those are different.
Yeah, and then Connor, you were saying that obviously you're coming from an all boys school and there were girls in your class for maybe the first time, and then Niamh, you are obviously a female student. For any students who are wondering maybe what it looks like as a female student in an engineering course, and maybe what that looks like, or if you've had any concerns about that, Niamh, if you want to answer.
Yeah. So I went in expecting to actually notice it and feel like I would be one of the few girls in the class, but I actually didn't pay any attention to it. I think my year was almost 30% female, so obviously not 50-50, but it's actually quite good compared to some of the other engineering schools, I think, in Ireland. So I never paid any attention to it, honestly. I was never made aware of it. I always felt like there was a female presence there. So I don't really have much else to say other than it didn't occur to me ever, and none of my friends have ever mentioned that they felt they were underrepresented in it.
Yeah, and actually for students who came in 2019, the ratio of female students to male students was, I think it was 34%, which is the highest we've had, and it's slowly been going up every year. So yeah, as you said, you'll never be the only girl in your class, and you probably won't feel any pressure of that when you come to UCD anyway. So I think it's a nice environment for our female students to learn in. And career-wise, we have plenty of really good UCD engineering alumni who are female, who've gone out to do great things in the world of engineering. So I wouldn't let that hamper students maybe choosing engineering on their CAO. We've got a couple more questions, so I'll try and fit in as many as we can. I think we'll finish around 1:30 because we've already run over time. But there's obviously students who are wanting to know about employability. Both yous aren't finished yet. So what I can say is the UC Career Development Centre, they work a lot with their students to help you with things like CV clinics, workshops. They do mock interviews. Obviously for students on the 5-year program, that work experience, professional work experience is really important. But most areas of engineering at the moment are experiencing a shortage in the country. So for any discipline or stream of engineering that you do, there is good job opportunities. And roughly, I don't have percentages the student was asking about for all types of engineering, but they're upwards of 90% of our students are getting placed within the first 6 months of leaving. And for some streams, it's obviously even better, the likes of chemical engineering. Because it's such a small cohort of students, nearly 100% of students are placed before they even finish their course. So any stream of discipline or engineering that you're doing generally has good job opportunities. So again, if you're wanting to have a really good career afterwards, engineering is a great choice regardless of what pathway that you choose to do. I don't know, did either of you do study abroad while you were in third year?
No, I haven't, but from all accounts, it's an incredible opportunity. I've had a few friends who were doing it, a few friends this semester. It was cut short, but people went to Australia, Canada, America, and it seems like it was a really enriching experience. They got to be on a new campus, meet new people, and just see different ways of which engineering was taught and everything as well. So if you have the opportunity, I would say, and you're in something you're interested in while in UCD, definitely apply for it.
Yeah. And in terms of expense, in terms of expense, it's important to note as well, like your college fees don't change, so you still pay the same fee. So you're only paying for like your accommodation and essentially like food and any travel you want to do. So it's not like you know, over costs. It's kind of costs you're getting worth out of anyway. And a lot of people go and study abroad, and then in the summer they'll just travel that country because they're there anyway. So if you wanted to travel that country in the summer alone, you still have to fly over there obviously and kind of do the traveling aspects to it. So it's quite worthwhile, I guess.
Yeah, I know a lot of students are concerned with costs and things like that, as far as, particularly if they want to go to the States, where, you know, people are worried that that the price would be really a hamper to them doing it. But yeah, as I said, you don't pay any additional fees. The fees you pay for UCD that year cover your cost of going there, because UCD has these partnerships in place with universities across the world, that it's no additional expense to you apart from your own personal travel expenses. And then for students who are wanting to do it, you do have to get a certain grade point average. I think it's 2.8 GPA to be able to progress and do that year. But that's not it's 2.8 out of 4.2. So it's not as if you're asking to be top of your class to be able to do that experience. So yeah, if anyone's interested in that, it is a great, from what I've heard, any accounts I've heard from students have had a wonderful time doing it and make really great friends, and be able to see a different culture and a different kind of way of learning in other universities is really good. And particularly for students who are wanting to maybe do a master's but not in UCD, who are wanting to travel for their master's to get a feel for another university, that's something really good, as students do that in the past as well. Let me just have a look. We've had a question around estimated salaries. It's a big concern for students who maybe wanting to get jobs afterwards and how much they're going to get paid. What I always advise students is money shouldn't be the reason why you're doing engineering. Generally speaking, engineers do have some of the best starting salaries compared to other graduates. Ireland estimates at around €32,000 a year, but that's a very rough estimate, and it depends on the economy at the time, and it depends on what stream of engineering and the company that you're working for. But generally, they're good starting salaries, so I wouldn't worry about that either. And then Conor, you're from Dublin, so you probably didn't, but Niamh, did you do on-campus accommodation or
yeah, so I'm from Kerry, so I didn't know where I was going to stay or anything, but I went and visited the UCD campus and I saw the on-campus residences. So I actually applied for the Coc na Gaeilge, or the Irish Living Scheme in UCD. So I was on campus in an all-Irish speaking student accommodation, so you actually got a stipend for being part of that. But living on campus, I would really recommend it if possible. If you're coming up to Dublin for college, it's a really great way to meet people outside your course, and even it's just useful to be on campus in the beginning because it's quite intimidating. Moving up to Dublin from Kerry, like, it's very different. So to have everything nearby, it's a good way to ease you into university life up at Dublin. And then after first year, I moved into a private accommodation off campus with friends of mine. So it's a good way to get to meet new people as well outside of your course. And it's quite social, and yeah, I would if possible, I'd recommend campus accommodation for first year.
And then we got a question around how many places are available to students who want to do engineering. From the CEO system, we take 265 students in every year, and that gets reevaluated every so often. So at the moment it's 265. And then we also take, obviously, people from the HERE scheme, DARE scheme, international students. So it brings you up to a class size of roughly around 300 students in first year, which can seem intimidating, but as you break into your different pathways, then your class size obviously gets smaller and smaller, and you get to know kind of really well as you progress through your degree. So it's about 265 students from the CEO system that we take in every year. So I think we might finish just on one more question, maybe make it a fun one. We've had someone ask about your thoughts on Elon Musk's method of space travel. I don't know if anyone was watching the launch at the weekend. Maybe if you wanted to comment on that.
I wasn't really watching it, but I guess, Elon Musk is kind of constantly pushing the boundaries, and that's the brilliant thing with engineering and any of that kind of science related stuff. I guess the boundaries are constantly pushed, and yeah, I guess it's really cool in that sense.
Yeah, to be honest, I haven't been paying too much attention to it, but it's exciting, and if that's an area you're interested in, I'm sure it's extremely exciting to you. It wouldn't be a particular area of interest for me. The moment I'm more reading up about coronavirus vaccines and things like that, so not my particular area of interest, but I'm sure it's super exciting, and like Conor said, it's just pushing the boundaries, and that's what engineering aims to do always. Yeah, be creative and finding new solutions and new ways of doing things.
Yeah, maybe if we had someone for mechanical engineers on, it would have been a question to ask. So I think that's all the time we have really for questions at the moment. I'll follow up with some of the other ones that are left unanswered afterwards, and I'll send some links obviously to some maybe interesting information for our students. I'll send the link to the video today because I know some people had an issue with maybe viewing some of the presentations earlier, so I'll send a link so you can watch that again if you need. But thank you to everyone who participated today. Thank you to you both for answering all our questions. Before I finish, I did say at the start we were doing an Instagram kind of competition. So if people wanted a chance to win our goodie bag and our Just Eat voucher, all you have to do is go over to our Instagram page. It's UCD Eng Arc. Follow us, and then there is a post, I think it's first on the grid, about the summer school, so just like that post as well, and then I'll randomly choose a winner tomorrow afternoon sometime, and I'll direct message you to get you your prize to you. But again, thank you everyone for participating. Hopefully you'll watch maybe some of the other summer schools that are going on, and then for anyone who's coming to the architecture one, I'll see you again on Thursday. So, thanks very much.